Thank you for watching Creating a Spatial Model in ERDAS Imagine by Hexagon Geospatial eTraining. In this module, you'll be introduced to the spatial modeler, understand its basic components, and finally build and execute a model. The spatial modeler allows you to build a flow chart that contains operators strung together logically to produce output results. Real-time previews and visual indicators allow you to inspect the model as it runs, easily find and correct errors, and see the results before running the model. The spatial modeler has three main parts: objects, operators, and connections. Objects define the items that are acted upon or created in the model. Operators are the actions that are done to the objects. Connections tie everything together and define the flow of the model. Objects and operators have ports that are used to define input and output values, including connections to and from other operators. The number of ports seen on an object will be different if the object is used as an input object or as an output object. Red ports let us know that there are arguments that are not yet defined and either need a connection or a value associated to it. If the port is gray, it's either defined with a suitable value or the port is used to define an optional value. The model we'll create today will use two input raster objects along with a matrix. We'll run a convolution operator to create a custom pan-sharpened image. Before running the model, we'll preview the results by adding a preview object to the model. Finally, we'll run the model and generate an output image. To get started, I have ERDAS Imagine open with two viewers showing the QuickBird satellite imagery that I'll use as inputs to our model. In Viewer 1, I have the higher resolution panchromatic image, and in Viewer 2, I have the corresponding multispectral image. The model we'll build will take these two images as inputs and create a pan-sharpened output image that contains the high resolution of the panchromatic with the band information from the multispectral image. I'll zoom in to show the difference between the images. As I zoom in and view finer detail, it's easy to see the spatial resolution and band differences between the two images. Now let's open the spatial modeler and build our model. For now, I can clear the other viewers. From the Toolbox tab, I'll select Spatial Model Editor. You can see we now have a Spatial Modeler Editor window for building our model. Also, a new tab, Spatial Modeler, has been added along the ribbon, providing tools to use as we build our model. On the far left, we see the Contents pane specific to the Spatial Modeler, and on the far right, we see an Operators pane. This pane gives me quick access to all predefined operators available when building a model. To start building our model, we'll first need to add an input raster operator. From the Operators pane, I can expand the input category, raster, and drag raster input into the viewer. Double-clicking on the operator opens the Properties box. For our first input raster, I'll add QB05 Cherokee pan.img. Ensure the interpolation is set to bilinear and set Read As to float. Then I'll click OK. Once I click OK, the ports turn gray and a label has been assigned based on my defined criteria. Next, we'll add a matrix. Again, from the input operators, I'll drag matrix, kernel matrix input into the viewer. I'll double-click the operator to open and define the properties. For this matrix, we'll click From Library and select the default 7x7 low pass. Click OK, and OK to the matrix dialog. Next, we'll need to add the convolve operator. We can use the keyword search in the Operators pane to easily find it. In the text window, I'll type CON. As I type, the filter is applied and I quickly see the operator I'm looking for. I can select it and drag it into the modeler window. I'll clear my search by clicking the X in the upper right-hand corner. Now I'll connect the inputs to the operator. First, I'll connect the raster out port to the raster in port on the convolve operator. I'll simply drag the raster out port and drop it into the raster in of the convolution operator. I'll do the same with the matrix port to the kernel port. Now I'll add another operator. I'll expand the math and trig category, scroll down, and add divide to the model. I'll connect the output port from raster input to input port 1 and raster output from the convolve operator to input 2. Now we'll add the last raster input operator and double-click to open the properties and define it. I'll add QB05 Cherokee MS.img as the input image, set the interpolation to bilinear interpolation, and read as to float, and click OK. Now I'll add the multiply operator from the math and trig group. I can connect the output from divide and the raster output port from raster input to object. Next, let's generate a preview. From the output operators, I'll expand view and add preview to the model. I can connect the output port from multiply to the preview object. From the execute group on the spatial model tab, I can click the preview button. This runs the model, opens a preview viewer, and loads the preview of the output image. The model can be resized to the extent of the smaller model window. You can also see green check marks on each object and operator, indicating the model has not encountered any syntax errors and is able to run properly each step of the way. If there are any syntax issues with the model, a red X would appear instead of a green check mark. This allows you to see specifically where the model has run into an error and allows you to open the operator directly and fix it. We can use the zoom tools to take a closer look at the preview results. We started this model with a 7x7 matrix. We can make changes to the model using the matrix property box and view the on-the-fly results in the preview window. First, we'll select the matrix object to activate the properties box. I can change the kernel name to 3x3 and see the results update in the preview window. Next, I'll try a 5x5 and again see the change. This is a great way to modify input values and view the results before running the model. For this model, I'll return it to the original 7x7 matrix. We're done with the preview window, so I'll go ahead and close it. On the Spatial Modeling tab, I can use the Fit to Frame button along with my mouse wheel to resize the model to the viewer. Now I can add the final output object. From the output category, I can expand raster and choose raster output. I'll attach the raster output from the multiply operator to the raster output object. I'll define an output file name, in this case resmerge.img, set the data type to float 64-bit and the file type to continuous, and click OK. Before running the model, I'll set the processing properties. There are several tabs in this dialog box with many different processing options. For this model, we'll set the cell size rule to minimum of all inputs in model. The window rule has many options including intersection, union of the inputs, specify, and others. I'll select specify and define the corner coordinates used to define the subset boundary for the output image. In this model, we use the default options for the projection, area of interest, and operator tabs. These can all be modified based on the needs of your specific model and output criteria. Once everything is defined, I can click OK to the processing properties. Now I'll save the model by selecting File, Save As, Save Model As, give the model a name, and click OK. Now we'll run the model. From the Execute group, I can click Run. The check marks indicate the model is running properly without syntax errors. In the lower right, I can see the status bar showing the model is running. I also see the raster output object showing the status of the image being processed. Once the indicator shows 100%, I can close the model. I'll open a new 2D viewer and load my results. Here is resmerge.img. Notice that it has been subset based on the corner coordinates that were defined in the model. Thank you for watching this e-training module on the ERDAS Imagine Spatial Modeler. For more e-training from Hexagon Geospatial, visit the Intergraph support site, log in, and follow the link on the right to e-training. We'll be adding content frequently, so please check back often.